In a class of 10 students, 7 speak English, 4 speak French, and none speak neither. Wait a minute, if there's only 10 students, and I've got 7 and 4 and 0 adding to 11, what's going on? Obviously, there must be a student who speaks both. I'm going to show you how to use a Venn diagram to describe this. In my class of 10 students, there are English speakers and French speakers, and there may be some overlap. If I've got 7 who speak English and 4 who speak French, and none outside those circles who speak neither, okay, none outside, then these add to 11, but there's only 10 students, so there must be one who speaks both. And then if there are 7 who speak English and 1 who speaks both, there must be 6 left who speak only English. And if there's 4 who speak French and 1 who speaks both, there must be 3 left who speak only French. So in my class of 10, double check, there's none who speak neither, 3 French only, 1 more making 4, plus 6 English only, making 10. Let me show you another example. In a group of 85 students, 47 study Maths A, 48 study Geography, and 6 study neither. We have to calculate the probability that if I choose a student at random, they study both subjects, or they study only Maths A. So, draw up a Venn diagram. In my universe, which in this case is just a group of 85 students, I have Maths A and I have Geography. I usually find it easiest, if I can, to put the 6 who study neither outside already. Now I have Maths A and Geography. There's 6 who study neither. How many are left? 85 minus 6 leaves me with 79 students. In those 79 students, I've got 47 doing Maths A and 48 doing Geography. Well, 47 plus 48 makes 80, 95. If there's 95 who study Maths A and Geography, and there's only 79 students to choose from, then how many go in the middle? How many do both? Well, how many too many do I have? 95, take away the 79, will tell me. I could probably do that in my head. 95 minus 80 would be 15, so there are 16 students who must study both. If there's 16 who study both, and there's 47 doing Maths A, then how many do only Maths A? 47, take away 16. Just to make sure I don't make a mistake, 47 takes 16 is 31. And if there's 48 doing Geography, but 16 of those also do Maths A, there must be 32 left doing Geography. Double check. Out of 85 students, I've got 6 doing neither, 32 doing only Geography, 16 doing both, and 31 doing only Maths A, for a total of 85. So now let's try answering the question. If I pick a student at random out of this 85, what's the probability that they study both subjects? Well, it's out of 85, and how many study both? 16. What's the probability that they study only Maths A? It's still out of the 85. There's 31 that only do Maths A. And there are your probabilities. You can also use a Venn diagram when there are 3 groups. Let me show you how. In a group of students, 26 study biology, 20 study physics, and 11 study chemistry. 10 students study biology and physics, 9 study physics and chemistry, and 8 study biology and chemistry. And 6 students study all three. How many students are in this group? How many study biology but not chemistry? And how many do not study physics? So set up your Venn diagram. Only this time we're going to have 3 intersecting circles. Biology, physics, and chemistry. Notice there is a section where they all intersect. There are sections where each one intersects with one other, and then there are the bits left over around the outsides. So, it's actually easiest with a problem like this to work from the inside out. From the inside out. There are 6 students who study all 3 subjects. 8 of them study biology and chemistry, but 6 of them study all 3, so there's only 2 left to make 8 studying biology and chemistry. 9 of them study physics and chemistry, but there's already 6 who study all 3, leaving 3 to do physics and chemistry but not biology. There are 10 who study biology and physics, but there's 6 already accounted for, leaving 4 who study biology and physics but not chemistry. Okay, we're nearly there. There are 11 students who study chemistry, but I've already got 5 and 6 make me 11. So there are actually no students who only study chemistry. All the students who study chemistry do at least one of the others. There are 20 students who study physics, but I've already got 7 and 6 is 13, so there are 7 students left who study physics, but I haven't already recorded as studying biology, chemistry, or both. And then there are 26 who study biology. Well, if 26 study biology, but I've already got 12 accounted for here, there must be 14 more who aren't doing one of the others. Now I'm assuming there's no students here doing none of them, so my total number of students is just add up those numbers. Let's do it carefully. 14 and 4 and 7 and 2 and 6 and 3, and that's all. Means there's 36 students in total. How many study biology but not chemistry? Well, this is the chemistry circle. So there are 14 plus 4, 18 who study biology but do not study chemistry. 18 students. How many do not study physics? Well, this is the physics circle, so there are 14 plus 2 plus 0, or 16 students outside the physics circle.